Okay, I'll be going over the solutions for our review quiz. So for the first problem, we need to go through and find the derivative. So f prime at x is going to be 3 halves x to the 3 halves minus 1. And so f prime at 4 is going to be 3 halves 4 raised to the, 3 halves minus 1 is a half. So that's going to give us 3 halves times 2. And those are going to cancel, leaving C. Okay, our next problem we have is a volume problem or area problem. And it wants to know which of the following is going to be the area of the shaded region. So notice that all of this is that shaded region, and that's going to be y equals f of x. So our top function, our top boundary to the bottom boundary is going to be d minus f of x. So automatically we see there's not going to be any other answer choices that would have that. And so we see that we have answer choice B. Okay, our next problem has an infinite limit. And so here, this is where we looked for our dominating power in the numerator and dominating power in the denominator. And notice that these are equal, so they do essentially balance each other, and so my answer is 3. Our next problem is an implicit problem. And so here we need to go through and find our derivative and then actually solve for dy dx. So let's go through and find the derivative of each term. We're going to have 3x squared plus 3 times, and we need to do our product rule here. So we have first times the derivative of the second, which is going to be 1 dy dx, plus second times the derivative of the first. And then we have plus 6y squared dy dx equals 0. And now let's go ahead and expand that parentheses. So we have 3x squared plus 3x dy dx plus 3y plus 6y squared dy dx equals 0. And now we're going to move everything that doesn't have dy dx over to the other side. And so I have 3x dy dx plus 6y squared dy dx equals negative 3x squared minus 3y. And now we're going to factor out dy dx. And that's going to leave us with 3x plus 6y squared equals negative 3x squared minus 3y. We are going to divide both sides by 3x plus 6y squared. And it looks like we can simplify each term by 3. So I am going to go through and cancel out. So notice that we have those to cancel, and we should have that 2 in front of the y squared. So it looks like my answer is going to be A, is the one that matches this. Okay, so our next problem is an area problem. And with this area problem, notice that they've already given us the boundaries from 3 to 4. And they've given us the curve, so whether or not we draw this, it's really not going to make that big of a difference. So we're going to just go ahead and integrate from 3 to 4 of 1 over x minus 1 dx. And so for this one, we can choose to do a u sub if you want to, and let that u be x minus 1. So du for dx equals 1, and so du equals dx. And so we can come back over here and integrate, and we would get 1 over u du And we can even adjust our endpoints, and we're going to sub in. So that's going to give me 4 minus 1. And then over here, when I sub in, that's going to give me 2 minus 1. And so, or 3 minus 1, sorry. I was thinking of the answer there. That's going to give me 2. And so when I integrate this, I do have the natural log, the absolute value of x, evaluated from 2 to 3. And so I'm going to have the natural log of 3 minus the natural log of 2, which is going to condense to be the natural log of 3 over 2. So that's going to be answer choice D. Okay, now we have the equation of a tangent line, and a quick review here. That's going to be y minus y1 equals m times x minus x1. Now we already have our x1 and y1 given to us. We need to find our slope m. So to find m, which is our slope, we need to do the derivative and substitute in our x value. So y prime, we're going to have the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now we need to evaluate y prime when x is 1. So for our first parentheses, we're going to get 3 minus 2. 2 minus, and if we substitute in 1 over here, we're going to have 5 times 3. And that's going to be all over 1 squared. So it looks like we're going to have 2 minus 15. So we get negative 13 for our slope. And so now we are ready to go ahead and sub in our equation. So we're going to have y minus 5 equals negative 13 times x minus 1. So that's not the form that we're given, so we're going to have to do some rearranging. We have y minus 5 equals negative 13x plus 13. I'm going to move that x over, so we have 13x plus y equals, and I'm going to add 5 over to the other side. It's going to give me 18, so that's going to be answer choice B. Okay, with our next problem, we are doing our derivative. And so here, since we have a polynomial, then we're going to just take our derivative of each individual term. We're not multiplying or dividing, so we're allowed to do that. And so first thing, I know the derivative of tangent is secant squared x. So I automatically can get rid of the first 3. Now, if we did not, because I think a lot of people forgot what the derivative of cotangent x is, looking at my answer choices, it's got to be cosecant squared x. But again, we have a rule that tells us that the derivative of anything that starts with a C is negative. And a lot of us forgot that. So the derivative of anything that starts with a C, whenever we're talking about all of our trig stuff, is negative. So that's actually going to be a plus sign there, and that's going to be answer choice E. Okay, for this problem, I think we forgot some of our trig values here. Now we will have to do the product rule. So f prime at x, we have the first times the derivative of the second plus the second times the derivative of the first, which is chain rule. So we're going to have 2 times x minus 1 to the first times the derivative of the inside. Now we're ready to substitute in f prime at 0. So this whole part here, that's going to be negative 1 all squared, which is 1, times cosine of 0 is 1. Plus, and then over here, sine at 0 is 0, so that whole rest of the term is going to go out to 0. So my final answer is D. For our next problem, again, we have PVA, so position, velocity, acceleration. we're given acceleration, and I want to know the position function. So I'm going to have to move up this chain, which is your antiderivative. So let's take our acceleration, and I know that my velocity function is going to be equal to the integral of my acceleration. So velocity's function here, if I go through, I know v at t is going to be equal to 3t squared minus 2 times t plus c. And then I know that if I plug in a 3, my velocity is 25. So I'm going to get 27 minus 6 plus c. And so putting this together, we have 21. Move that over. So we have c as 4. So automatically we know that the velocity function is 3t squared minus 2 times t plus 4. Now, I need the position function, but I have enough here that I can answer my question. I know it's not going to be a or b. I know if I integrate this again, because I need to get to position, and that position function, x at t, is going to be the integral of v at t. So I know I'm going to have t cubed, so that's going to get rid of e. And notice that here, I'm probably going to end up with a 4t from there. So my answer is going to be C. Okay, for our next problem, we are going to look at just some properties. And really, this is just testing what we remember about our integration. Here, we cannot separate that by any means. And this is not always true for all real numbers. So the only answer there is answer choice 2 or B. Okay, our next problem is a U substitution, but I think a lot of people forgot that this stuff here is still under the radical. You are going to let U be x cubed plus 1. du dx is going to be 3x squared. And again, when we solve for that dx, we have du over 3x squared equals dx. We're going to come back and check that. So I'm going to have 3x squared over the square root of u, and then times dx, but dx is du over 3x squared. Those do cancel, so we have something that we can most definitely go ahead and integrate. I would rewrite this to be u to the negative 1/2 du. And now whenever we go through, we're going to add 1 to that exponent. And again, that tells me what to divide by, plus c. So this is going to be u to the 1/2 over 1/2 plus c, or 2u to the 1/2. But we knew that u was x cubed plus 1, all raised to the 1/2, plus c. So that's going to give me answer choice A. All right, our next problem, we need to find the derivative's value at 0. So here we do need to do our chain rule. F prime at x is going to be 2/3 times x squared minus 2x minus 1 raised to the, and if I subtract 1, then that's going to give me negative 1/3. And then times the derivative of the inside. All right, now we're going to sub in our 0. So we're going to have 2/3 times, and that's going to be 0, 0, here's negative 1 to the negative 1/3 times negative 2. Now this negative 1 to the negative 1/3, that's just the cube root, 1 over the cube root of negative 1. Let me write that in. You're going to have 2/3 times 1 over the cube root of negative 1 times negative 2. That's still, all of that's still going to be negative 1. So we're going to end up with a positive 4/3, which is going to be answer choice A. All right, our next problem is going along with our second fundamental theorem of calculus and with the accumulating problems that we saw, every time we're doing the derivative of the integral, then those are going to cancel each other out. Now, you can think of it to be very similar to if I have the square root of x squared, that's going to just cancel each other out, and you're basically left with the absolute value of x, and in most cases, you're going to have x. So the same idea here. These are inverses. You have the derivative and really the idea of an antiderivative. So I'm going to end up just really replacing right here that u, and so you're going to end up with cosine of 2 pi x. And so that's going to be answer choice D. Okay, for our next problem, and this one has really tricked several people. This goes back to one of our little shortcuts that we saw where if we had e raised to the natural log of x, always reduces down to just x. So let's see if we can get that 3 to move. Keep in mind that 3 is the coefficient of the natural log of x squared. So that 3 is going to move up to be an exponent. So that's going to be the natural log of x squared all cubed. And keep in mind here, now we've got this situation. So the only thing that's going to reduce down to be is x squared all cubed, which is really just x to the 6th. So having all of that rewritten, now I just need to know what is the derivative of x to the 6th, which is 6x to the 5th. So answer choice E. And for our last problem, we're looking for concave down. And we know that our function is concave down whenever the second derivative is going to be negative. So let's find that second derivative. Well, the first derivative is going to give us 12x cubed minus 48x squared plus 48x. Okay, now our next problem here, we need to go on to that second derivative. That's going to give us 36x squared minus 96x plus 48. Now, if we had a graph of this, we could pretty quickly pick out where that graph was negative. So I'm going to factor this, and it looks like we have a common factor of 12. So I'm going to factor out 12. We get 3x squared minus 8x plus 4. Now we're going to go through and see if we can't just factor. We've got 3x and x, and we need to have our signs to be the same. So to get 4, let's try 2 and 2. And signs are the same. They're both negative. And so that looks like that might work. And I'm going to set that equal to 0. So x is going to be 2/3, and then x is going to be 2. And notice that these answer choices are over here, so then it looks like that might be lining up pretty nicely. So now let's do a sketch. Our second derivative is a parabola. Notice that the leading coefficient is positive, so the parabola is going to be turned upward. And these two values, this is where we're crossing the x-axis. So a rough sketch here, there's y double prime. Here's 2 and 2/3. So notice that this graph is negative between 2/3 and 2. So that's going to give us answer choice E.